Have you ever wondered how the world's largest hot desert could quench its thirst and become an oasis? What are the secrets of the incredible Sahara fog nets and their amazing capacity to create extensive water in the midst of a dehydrated wilderness? Join us on an exciting adventure as we explore an amazing idea that harnesses the power of fog in the Sahara. The Sahara, the world's largest hot desert and the third largest overall, trails only the cold deserts of Antarctica and the Arctic in size. Its vast expanse covers approximately 3.6 million square miles to the area of the United States, encompassing nearly a third of Africa's landmass. A study published in the journal Science Advances in 2019 reveals that the Sahara endures a harsh, inhospitable desert climate today, but it undergoes dramatic cycles every 20,000 years, transitioning from a barren desert to a lush green oasis. Researchers examining marine sediments with Sahara dust deposits dating back 240,000 years found that these cycles coincide with slight changes in Earth's axis tilt, which influence monsoon activity. When the northern hemisphere tilts a mere degree closer to the sun, increased sunlight boosts monsoon rains, leading to a vibrant green landscape in the Sahara. In ancient times, the Sahara hosted a thriving ecosystem. Archaeologists have discovered prehistoric cave paintings, rock art, and other remnants that offer insights into life in the once verdant Sahara. Pottery remains to suggest that around 7,000 years ago, the region supported herders raising livestock and harvesting plants in an area that is now a dry, arid desert. Over the past 2 millennia, the Sahara's climate has remained relatively stable but exceedingly arid. Northeastern winds deplete moisture from the desert air and propel hot winds toward the equator, sometimes causing intense dust storms with zero visibility. The Sahara's precipitation levels, reported in a 2014 study from the journal American Meteorological Society, range from almost none to about 3 inches of rain per year, with occasional snowfall at higher elevations. Average temperatures in the dry, arid desert reach around 60 to 77 degrees Fahrenheit, with scorching summer days soaring up to 120 degrees Fahrenheit and bitterly cold winter nights plummeting to 0 Fahrenheit, according to the University of California Museum of Paleontology, Berkeley. Surprisingly, the Sahara Desert's area has expanded by nearly 10% since 1920, as indicated by a 2018 study published in the Journal of Climate. Another study from 2020 in the journal Scientific Reports projects a continued comparable expansion until 2050. While all deserts experience fluctuations between wet and dry seasons, human-caused climate change, combined with natural climate cycles, has contributed to the Sahara's accelerated growth and reduced shrinkage. The 2018 study estimates that approximately 1/3 of the desert's expansion is attributable to human-driven climate change. However, the Sahara Desert has lately discovered a solution to its water dilemma. So, what is their new strategy? Due to unusually little rainfall, the southwestern region of Morocco, notably the Anti-Atlas Mountains, suffers considerable water-related issues. Droughts are severe in this dry area, making water scarcity a major issue for the local communities. Water scarcity complicates agricultural activity in the area, making farming uncertain and challenging. As a result, the local population, primarily men, is forced to seek employment in urban areas, while women stay in villages and must travel considerable distances to obtain safe drinking water from wells. However, due to falling groundwater levels, even these wells are drying up, aggravating the region's water crisis. Despite its proximity to the Atlantic Ocean, the region's distinct climate is affected by a transitional zone inside the Sahara Desert, resulting in aridity and a scarcity of water supplies for survival and development. In Morocco's southwestern region, 60% of the local population lacks access to running water in their houses, adding to the difficulties of daily life and impeding development. This critical issue reflects the region's severe water constraint dilemma. Furthermore, it is worth noting that water scarcity affects approximately 40% of the world's population, demonstrating that water scarcity is a pervasive issue affecting billions of people worldwide. The lack of clean and safe drinking water is a substantial impediment to human well-being, agricultural production, and economic development, necessitating creative solutions to this vital issue. To address water scarcity issues in southwestern Morocco, an innovative technology known as aqualanus has been implemented to harvest water from fog. This cutting-edge device gathers fog and turns it into safe drinking water for 16 isolated settlements in the region. Aqualanus technology has proven to be highly effective in delivering a consistent and long-term source of clean water for the people in the area. The gathered water is utilized to irrigate agricultural fields, renewing formerly desertified land and changing it into fertile farmland, in addition to satisfying critical drinking water needs. The success of this project has substantially improved the people's living conditions, eliminating their reliance on distant water sources and allowing them to engage in more productive activities closer to their houses. Aqualanus deployment provides a promising alternative for managing water constraints and promoting sustainable development in dry locations such as southwestern Morocco. Aqualanus has the world's largest water catching system, with 1,682 square meters of mesh space. Because of its huge size, it can easily capture water from fog, making it a valuable instrument in the fight against water scarcity. The system's design is specifically intended to survive the region's extreme conditions, including as strong winds reaching up to 100 kilometers per hour, which are typical in the area due to its proximity to the Atlantic Ocean. Aqualanus is designed with rubber expanders to minimize the impact of these intense winds, preventing damage to the structure. Furthermore, the fog nets include flexible trails that can alter and move with the wind, ensuring stability and maximizing water collection effectiveness. When compared to standard flat woven mesh fabrics, the system's 3D knitted fabric has a bigger surface area for water generation, increasing its overall effectiveness in catching water from fog. Aqualanus has successfully supplied ample and safe drinking water to communities in southwestern Morocco as a result of technological breakthroughs and sturdy design characteristics, providing a sustainable and reliable water solution in the face of tough environmental conditions. The Aqualanus fog capture facility in southwestern Morocco has considerably improved the region's water supply. This transition has had a significant impact on the surrounding community. Villagers may now focus more on education now that they have a consistent and reliable source of clean water. As the burden of fetching water from distant wells has been lifted, the availability of water has allowed youngsters, particularly females, to devote more time to school and academics. Furthermore, the newly discovered water supplies have allowed for agricultural expansion in the area. Villagers can now grow fruits and vegetables because they can irrigate their fields, transforming previously arid territory into rich farmland. This has increased the availability of fresh produce for the local population, while also creating new revenue options. Farmers can sell their excess produce in local marketplaces, so contributing to the region's economic growth and prosperity. The project's success has spurred hope for long-term development in the region, and it has the potential to serve as a model for other countries suffering similar water scarcity issues. The Aqualanus Fog Catching Project has unlocked different prospects for growth and improvement by addressing the fundamental demand for water, boosting the community's well-being and overall quality of life. However, in comparison to when stakeholders were developing fog catchers in Chile's Atacama, they were able to build 6 of these fog nets thanks to money from the Australian Embassy. They captured almost 1,000 liters of water every day using nearly a mile of tubing and a fiberglass container over a 2,600 square foot area. Darum's fog collecting site is the largest on the planet, with over 10,000 square feet of installed capacity, and the 1,600 residents of this remote region will each have an 18-liter per day water supply sourced entirely from fog collection nets. It's yet another example of modern ingenuity from the global south. California, which is suffering from a drought and has already stolen water-saving tactics from India, might use these nets throughout the shores of San Francisco, Oakland, Point Reyes, Monterey, and Santa Barbara. Mount Baut Mezguita is remote and dry, and fog nets installed closer to the coast at a lower elevation might supply 3 times as much water. One of the clearest markers for entrepreneurs, as with everything in economics, is how people vote with their feet. In conclusion, the Sahara fog nets have opened a door to new opportunities in the middle of the desert, bringing hope and life to a place that was once dry and barren. Water scarcity is being fixed with new ideas and hard work, turning dry areas into places where people can live and grow. Thanks for watching. If you found the video as interesting as we did, don't forget to subscribe to our channel and hit the bell so you don't miss our future updates to find sustainable solutions and ideas around the world.